Vibe coding security bill is coming due. In Q1 2026, CVEs formerly linked to AI-generated code went from 6 in January to 35 in March, a 6x increase in a single quarter. Researchers estimate the real number is 5 to 10 times higher. In this video, we look at the data, the real incidents, and the concrete steps professional developers use to stay safe while still using AI coding tools. The Georgia Tech Vibe Security Radar tracks CVEs formerly attributed to AI-generated code. January 2026, 6 CVEs. February, 15. March, 35. Across all 74 confirmed cases, the breakdown by tool shows 27 linked to Claude Code, with GitHub Copilot, Cursor, Devin, and Ether accounting for the rest. But the confirmed count is almost certainly the tip of the iceberg. Most AI coding tools don't tag their commits differently from human-written code. Researchers estimate 400 to 700 cases exist across the open-source ecosystem that haven't been formally attributed yet. On February 2, 2025, Andre Karpathy, co-founder of OpenAI and former head of AI at Tesla, posted on X, "There's a new kind of coding I call vibe coding, where you fully give in to the vibes, embrace exponentials, and forget that the code even exists." That post had 4.5 million views. It named a practice millions of developers were already doing. Collins English Dictionary named it Word of the Year for 2025. By early 2026, 41% of all code written globally was AI-generated. The vibes were good. The CVEs came later. Veracode tested over 100 large language models on security-sensitive coding tasks across Java, Python, C#, and JavaScript. The result, 45% of AI-generated code introduced OWASP top 10 vulnerabilities. That number is not a bad day. Veracode ran multiple testing cycles through 2025 and into early 2026, and the pass rate did not improve, despite vendor claims that models were getting safer. The worst category, log injection, with 88% of samples failing. Cross-site scripting, 86% failure rate. Java had a 72% failure rate overall. These are not obscure edge cases. These are the first 10 vulnerabilities every security course covers. Here is what OWASP vulnerabilities look like in AI-generated code specifically. Broken access control, row-level security disabled by default, missing authorization checks on endpoints. Cryptographic failures, hard-coded API keys and source code. Weak algorithms like MD5 suggested. Injection, SQL injection via unsanitized inputs, log injection through unvalidated log statements. Security misconfiguration, open database policies, default credentials left in config. The AI generates code that works. It doesn't automatically generate code that is secure. Those are two different properties, and the training objective optimizes for the first one. GitGuardian's 2025 State of Secrets Sprawl report found 29 million secrets leaked on public GitHub in 2025, the largest single-year jump ever recorded, a 34% increase year-over-year. Leaks tied to AI services specifically surged 81%. AI-assisted commits had a 3.2% secret leak rate versus a 1.5% baseline for non-AI code, roughly double. GitGuardian also flagged a new category, 24,008 unique secrets found exposed inside Model Context Protocol configuration files. MCP is how you give AI agents access to tools, and developers are putting API keys directly in those config files. The most visible example of what this looks like in production, Moltbook, an AI social network launched January 28, 2026. The founder built the entire platform with AI prompts, no code reviewed, no security audit. It launched to significant attention. 3 days later, security researchers at OWASP found the production database was completely open. 1.5 million API authentication tokens, 35,000 email addresses, private messages between agents, all accessible. The root cause was a single unconfigured Supabase setting. Row-level security was off. The AI-generated working code. It just didn't configure the data access layer. Nobody checked. Moltbook is not an isolated story. A separate analysis of 1,645 web applications built on vibe coding platforms found 2,038 critical vulnerabilities across 1,400 of them. 70% shipped with row-level security disabled. That means any authenticated user could query, modify, or delete any other user's data with a simple API call. The vulnerability is obvious once you know to look for it. But when you accept AI output without reading it, you don't look for it. The AI presents a working product. The developer ships it. The security team finds out from the breach notification. There are 3 structural reasons AI-generated code trends toward vulnerability. First, the training objective is functional correctness, not security. If the code runs and returns the right output, the model is rewarded. Security properties like least privilege and input validation are not built into that reward. Second, AI tools make developers much faster, 3 to 4 times more commits. Apiro measured one enterprise where AI adoption turned 1,000 monthly security findings into 10,000. Privilege escalation paths rose 322%. Architectural design flaws rose 153%. There are simply more PRs than reviewers can check. Third, AI models hallucinate packages. Roughly 20% of AI-suggested packages reference libraries that don't exist or have known CVEs. The first fix is test first. Write your tests before you generate code. Define what secure behavior looks like. Then ask the AI to write code that passes those tests. This forces the AI output to satisfy your criteria, not its own internal sense of correctness. For a user data endpoint, write a test that verifies unauthorized users get a 403. Then generate the implementation. The AI has to make the security check pass, not just make the endpoint work. The second fix is a SAST gate on every pull request. Static application security testing tools analyze code before it runs. SemGrep has free OWASP top 10 rules you can add to a GitHub Actions workflow in about 10 lines of YAML. If SemGrep finds an issue, the PR is blocked. No merge until it's fixed. This applies to AI-generated code the same as human-written code. The third fix is secret scanning at the pre-commit stage. Install GitLeaks, add a pre-commit hook, and any commit that contains something that looks like an API key is blocked before it ever reaches the remote. GitGuardian offers a free GitHub integration that does the same thing in real time for every push. The fourth fix is agent isolation. Every AI coding agent you give codebase access to should have minimum permissions. Read access to the files it needs. Write access only where necessary. No production credentials in the agent's environment. No shell access unless the task specifically requires it. The Codex CLI shell injection vulnerability discovered in early 2026, where crafting a malicious branch name could inject shell commands during task creation, is exactly why this matters. Agents with broad permissions are a new attack surface. Treat them like service accounts. The fifth fix is dependency scanning in CI. AI models suggest packages from training data with a knowledge cutoff. Those packages may now carry known CVEs. Running pip audit, npm audit, or governcheck in your pipeline catches this before it reaches production. Here is the security checklist you can apply today. Write tests before generating code. Add SemGrep with OWASP rules to every PR as a required check. Add GitLeaks as a pre-commit hook. Verify your database security configuration. If you're using Supabase, confirm row-level security is on for every table. Give AI agents minimum permissions, never production credentials. Read every AI-generated file that touches authentication, user data, or external APIs. Run a dependency audit in CI. Confirm that AI-suggested packages actually exist and are actively maintained. None of these steps are complicated. Most are free. All of them would have prevented the Moltbook breach. The verdict: vibe coding is not going away. 72% of developers use AI coding tools daily. 41% of all code written globally is now AI-generated. The speed gains are real. But as Simon Willison put it, writing code is now near free. The expensive part is architecture, test design, and domain knowledge. That has not changed. If anything, it matters more now. The AI can write the code. It cannot tell you what the code should do, who should be allowed to access it, or what happens when it goes wrong. That part is still yours. The developers who come out ahead won't be the ones who write the most AI-generated code. They'll be the ones who write the most AI-generated code that doesn't become a CV. If you like this video, hit the like button and subscribe for more tutorials.